Well, I'm really glad, as also having James here, to introduce you to Thomas Padilla, who's currently working at the University of Santa Barbara. And you told me it's 1 hour's drive north of LA. So Thomas come a far way to join us here today. Thomas worked for, I can't remember how many institutions, but also the Library of Congress, University of Michigan, held digital preservation positions.
Yeah.
And now currently you're working as a humanities data curator.
That's right.
Yeah. And one other thing is that some of the tool or the things you have to look upon in this session is Thomas has built a tool together with James Baker called the Sourcecaster. And you're going to look into that as well. I'm really excited about it to see what it offers. So welcome, Thomas.
Sure. Thank you. Okay, so I put this webcomic up because I think it's funny, and I think it's also relevant to maybe some of the challenges that you all were working through trying to install that laundry list of things that I asked you to install. I was probably the source of a lot of frustration and pain, and so I apologize for that. I do think it is sort of like a rite of passage in this community to go through the struggle of trying to install some of this stuff. Unfortunately, I hope that doesn't disincentivize you too much that you completely don't want to do this stuff anymore. Hopefully it's the case that now that you've made enough of an investment that you want to go over the cusp to be able to ask the interesting questions. I hope. I will say with respect to the workshops, right, we're going to do sort of like two different distinct things right now. We're going to have a section that's focused on sort of data preparation, data cleaning, and using OpenRefine. And then we'll have sort of a second module that leverages some of the different tools that we talk about in the Sourcecaster, the tool that Michael just alluded to. With respect to working through the installation issues, the way that I want to handle that is like this. So basically with each section, I'm going to talk conceptually about these areas of work, how they connect to research and so forth. And then I'm going to walk through a heavily documented tutorial that I'll share with all of you. Okay? And if you did successfully install, you can follow along. If you did not successfully install, it's going to be more of a demonstration, but I'm going to leave a big amount of time at the end of each section so I can walk around and work through either installation issues or execution of command issues. All right? Does that sound good? Yeah, okay, good. So we'll get started. Let's see if I have internet. Okay, so data prep. The way that I work with data preparation is typically in the humanities. I like to have fun with it. I don't know if because I'm in the humanities, that gives me exclusive license to use Star Trek references. But, it is what it is. But data preparation in the digital humanities, and just, data prep generally, it's really an underestimated aspect of the research process in terms of the amount of time and labor that it takes. Some researchers have suggested that it actually, 80% of the time, even prior to analysis, is focused on acquiring data from some place and then cleaning it and, normalizing it and performing these different actions to get the data into a shape that actually supports the type of questions that you want to ask. So this particular, presentation and workshop is really focused on, how do you think about doing that data work? And what might be a tool that could be helpful for you in terms of working with a particular type of data. If you did really want to dig into the weeds on data cleaning, data normalization, there's a statistician. I think he's a chief scientist at RStudio. His name's Hadley Wickham. He's put forward this concept called tidy data. There's actually a huge multidisciplinary community around this concept of tidy data. And essentially, it's a way to approach almost like in an algorithmic way, but without a computer, basically just like a conceptual model for working through creating data sets that support the type of questions that you might want to ask, right? So data tidying, it's the actions that you do to structure the data sets to facilitate analysis. It's pretty straightforward. A data set, the way that Wickham defines it, is simply a collection of values where every value belongs to a variable and an observation. Okay? Again, pretty straightforward. Okay, this is a little bit more focused, I guess. And I almost fell into the chord hole. It's probably the only time I'll ever say that on a stage. Okay, yeah, so tidy data. This comes into play particularly with tabular data, or data that might be in a spreadsheet, right? So to just think in a pretty rigorous way that, each variable forms a column in a data set. Each observation forms a row, and each type of observational unit forms a table, right? So this becomes particularly helpful when you're looking at a data set and you start to realize all of a sudden that you may have multiple variables within a column and then multiple observations on a row that don't really belong together. It really kind of muddies your ability to ask questions of the data. Today, during the hands-on portion, we'll mostly be working with tabular data. It's comic book data. Not seeing many excited faces. Sorry. It's comic book data. It's from the British Library, James's former institution. So hopefully there's some excitement that we can get out of that. We'll be thinking in particular about structuring data. And when I'm talking about structuring data, like I said, it's like the way that you organize data basically to support analysis. It's actually deceptively difficult to do. I don't know how many of you have been involved in the type of work where you organize data, like this. It's essentially a spreadsheet of comma-separated values, and you want to get to something like this, right? It's actually remarkably challenging to think about sort of like these elemental variables, right, and sort of coherent observations across each row. To the extent that you get to the visualization and you can actually do it in an elegant way, it requires like this rigorous, simple thinking. Or you could call it elegant thinking, I guess. But that's essentially what it entails. So I want to think about that a bit more. And then with respect to cleaning data or data normalization, oftentimes what that entails is, say you have like dates in different formats, or if you have differences in case, or if you have you have encoding issues with different types of data, you need to fix that. In the humanities, with cleaning data, we often think about how that sort of astringent, bleach-like characteristic has the possibility to sort of eliminate difference in the data where we might actually want it to stay there. So I have this particular example. This was a personal project with a cartoonist of color in Los Angeles who's created this database to sort of capture demographic data on cartoonists of color and then also gay cartoonists. And in preparing the data, I had in mind, basically I want to create like out of this like flat HTML table that they had on this website, this data in a JSON format. Because I had in mind that, maybe people can create cool D3 visualizations, dynamic things on the web. And in order to do that, that often implies some normalization or some cleaning, right? Cleaning of the data. I put it onto Figshare, but I included this note. Basically the way that the data has been collected is that authors and artists and illustrators and editors and pencilers, I think that's a role in comics. They submitted what they personally identified as their dissent, basically. And within a set of a little more than 800 people, we had over 160 different types that people self-identified as, everything from Afro-Bermudian to Black Irish. And so, possibly I could have moved down a process of normalizing this data or cleaning it and condensing, everyone into being African American rather than saying that they're, African Spanish or something like that, right? But that would be cleaning away the difference in the data that's actually meaningful to the people who submitted the data. So there's always that kind of balance when you're approaching a data cleaning operation in terms of how are you respecting, if there are humans involved in particular, right? How are you respecting their individual difference? Okay, so Google Refine, it's actually Open Refine now. This is basically it there. It's a power tool for working with messy data, okay? Pretty straightforward. It falls, kind of at the bottom of this pyramid that the data carpentry put together in terms of like skills and dispositions that you need to be successful in this like data science space. here with data and spreadsheets and some statistics and to be determined, I guess. One of the things that I also think would be a useful takeaway from this particular session is that oftentimes it's the case is that you come to a workshop, right? You have this workshop experience where you do some sort of thing with a computer, and there's usually a method, say like network analysis, a tool like Gephi, and then you have some sort of like network data in a CSV file, and then you do something really cool, right? You create this interesting visualization, and then you go home. You go home with your computer, and you kind of have this abracadabra-like kind of thing happen, right? You get the setup going, you have the tool installed, you go to put some of your data into it, and then nothing really happens, right? Part of the reason nothing happens is because that the instructors have put so much time into trying to identify and curate data sets that will work successfully within the space of an hour, right? Those are the constraints, right? They're trying to meet your expectations, and they're trying to interest you in a particular method and tool, and in doing that, they've kind of, in a way, sometimes not set you up very well to be successful when you go home, right? So one of the takeaways that we want from this is, with this particular tool, how might you be better empowered to clean and structure data on your own in like a real, like tangible way? The other sort of secret of, I'll just say digital humanities, we have all of these projects, often web-based projects, cool visualizations. There was the example earlier with Tableau, not a DH project, but it looks really cool, right? And then you think, well, maybe I might want to do something like that. And then you kind of get out your mental conceptual table and you start trying to tinker, and you're like, what is this thing for? And what is this thing for? And what does that thing do? And there are some approaches to trying to help people navigate that process of trying to figure out, well, how could I do a similar thing? How could I reverse engineer this project? One in particular that Miriam Posner put forward a couple of years ago is called How Did They Make That? It's a simple question. She takes a project, she asks a question, how did they make that? And then she moves through these sort of three sort of sections. Be like, what the heck is this thing? What are the tools that I would need to know? And what are alternative methods or resources that I could use to try and explore something similar? In reality, I mean, that's really useful, but in reality, it's actually it's still not enough, right? It's still really complicated. And oftentimes, the complexity is predicated on all the work that's gone into curating the data to actually be able to support the visualization or to be able to support the text analysis. If we look at this particular case, Kindred Britain, it's a project out of Stanford. The data underlying this was derived from a database that was built by a faculty member, I think in English, over a period of 15 or 20 years. And then the data was subsequently curated and restructured to support a relational analysis through the network, to support a temporal analysis through a timeline, and then also to support a spatial analysis through a map, right? So with each of those steps, there's been a curatorial approach and a series of design decisions and even some augmentation of the data to enable that work to happen, right? But not super clear from interacting with these elegant interfaces. One of the nice things about this project in particular is that they actually wrote a very fulsome series of documentation on how they approach doing this work. And it stands apart from a lot of other projects in this space is because this particular aspect of this project seems to have been treated with the same intellectual respect that was accorded to an essay about relationships between prominent families in Britain, right? Really stands apart in that way. So you can actually learn a lot from this. Again, so we're working with spreadsheet data, working with OpenRefine in particular. The hope is that we get to tidy data and that helps us maintain a sense of childlike wonder and happiness, maybe spinning in place like this. To be granular, the particular things that we'll be focusing on are removing data format inconsistencies, right? So in this particular instance, it's differences between the way that a space is represented, to split multivariable fields, and then also to fix inconsistent terminology. Okay, so I'm going to get started unless there are questions at this point. No? Okay. So if everyone can go to this URL, that's where we're going to have the actual tutorial. Okay, so I'll wait a sec while people pull that up. And I will say it seems like there was a mixed bag with the OpenRefine installation. I'm hoping that within each cluster of people that there's at least 1 or 2 people who successfully installed it. If you can cluster together, that would be great. Okay. James was talking about how much he loves wget earlier. And in my particular use case, really just to get like bulk access to cultural heritage data from institutions that don't necessarily, have not, what's a nice way to say this? Have not, yeah, I don't know. They had different user communities in mind. But there are some interesting steps in terms of trying to think in interesting ways about APIs that could make getting bulk access to cultural heritage data easier. Oftentimes, the APIs are focused on facilitating bulk access to the metadata, which is interesting, but it's not often the case that they give you bulk access to the actual objects themselves. Right. So, still area to be, or ground to be broken, or whatever, witticism, I guess. There are some institutions, I think James was mentioning. James, what was the one that's making it easier to use wget with? Europeana newspapers, I guess, makes it easier to use something like wget. At the University of Pennsylvania, they have a great project called OPEN, where you can use things like wget or rsync or anonymous FTP to bulk download the content. So for this particular use case, it's kind of like predicated on trying to understand the structure of a website, right? So it's often not the case that you can't just really just like use wget and say just like grab me all the stuff. You actually have to understand like how websites are structured in order to do that. I think some of the probably wasn't the intention, but James's section on sort of creating more of an orientation to how the computer is structured in terms of hierarchies of folders and things like that. It's not really dissimilar conceptually from how a basic website is organized. So, for this particular example, if we look at the, wait, that's not the browser, the Whitman archive, so Walt Whitman. And if you look at portraits of Whitman, I've often had the case, back in the States, particularly for history classes at the undergraduate level, that they like to use things like Omeka to create web-based exhibits of cultural heritage data, narratives around those exhibits, and they're often trying to find data, right? So when I see something like this, I'm like, oh, this is great. There are these images. There is like metadata for the images. I can view the images, but like, how do I get there's 128 images. Oh, and they're on 10 pages. But like, how do I get them? Like, how do I get the data? Like okay, I can look at it. And then I can click on that and it gives me a bigger one. But like, how do I actually get it onto my computer so I could do stuff with it? Right? That's where wget comes in. Okay? And part of the ability to use something like wget is you need to be able to instruct it to point at certain areas of a hierarchy of a website. Okay? So one of the things that I had done was I basically screen scraped the metadata from that page. Let's see if this opens. Okay. was just saying so many nice things about Excel, and it's not obeying. OK. So if you look at these URLs, essentially, if you have these forward slashes, they're indicating directory structure, right? If you think about like the paths to different files and things that you're working through with James, it's kind of the same thing in a website. It's just like there's this website, and then there's a folder called multimedia, and then within that folder, there's something called image 019. And then this is all just kind of extraneous like display information, not really related to the organization of the data itself. So if we look at that a little bit more closely, and I've tried to use some color coding to make this kind of digestible. Yeah, OK. So if we click on that URL, right? So click on this. And it takes us here, right? So this is image 001. So this is the first image in this data set. But I want this like high quality one, this bigger one that is conveniently in a directory called large. Right? Images large. It's a kindred spirit that I have out there. They have like a same way of thinking. But essentially what you do is you just work through that. And so like through the scraping, I got basically all of these URLs. And then I basically just looked at that URL and then just copied the pattern and then iterated this number until it captured all of the content. Does that make sense? So just kind of like working with the structure of the data, and then I created a set of URLs once I understood the structure that would capture the higher quality images. So once you get the URLs, once you understand the structure of the website, once you create the URLs that you need, you then essentially have almost like an address book in a plain text file that resolves to all of the objects that you want. Okay? So in this particular case, I had created this file here. It's a portrait.list text file. Let's see. Okay. Okay, so I'm going to go to the desktop, and I'll make a directory called Whitman. I'll move into the Whitman directory. And then if I remember correctly, let's see. James, did you tell them about the dragging the file into the... No? OK. So I have a pretty basic command here. You got kind of an introduction to something like it with the foreign relations use case. But essentially, it's just saying, hey, I want to use wget. Wait 10 seconds between each time that I ask the server for this data. Limit my download rate to 20K. Of course, you could also include no limitations. But then you might break stuff and it might feel bad. And then the I, which is just a flag, the I is just saying input a file for wget to reference. It's that address book that I was talking about. So if we include that, that might get messed up because of the, let's try. OK, so it'll download that at a max of 20 kilobytes a second. You can see that. Now it's going to pause for 10 seconds. At least it should. And then it'll just go on and on and on. Right? So conceivably, this directory could hold like 5,000 images. Right? And you could just let this run for a really long time and get all that data. The world is your oyster, right? And this is, basically exactly what I did in the foreign relations use case, right? In that case, it ended up being over 300 gigabytes of content. Who's used wget before? 1, 2, 3, okay, 4. Okay. I'm curious, do you guys have, oh, I have the box. Would any of you like to share how you've used it? Yeah?
Well, I participated in, what is it, we call it, Hack for DK. And what I did was based on the dataset that DBC contributed with, which was library lending data, where I collected all the authors who had a book lent out in 2014, and then I used wget to access Bibliotheksafgiften to see how much money they had received, and then I calculated how much money they received for every book they lent out.
Wow. Pretty cool. Thank you. Okay, so in the interest of time, I'm going to try and speed up a little bit. So FFmpeg, it's a very powerful tool. It's often used by media archivists or AV archivists or media preservationists to do all kinds of crazy stuff. In this particular use case, it's more about like if you had a media file, a moving image file, and you just wanted to separate out different kinds of data from it. So if you wanted to separate out the audio track, if you wanted to stop at a certain level, if you wanted to reduce its size, if you wanted to create an animated GIF, this tutorial will show you how to do that, right? The last time I taught this, my students mainly just created jokes with it, lots of animated GIFs for the internet, and seem to enjoy it. So, FFmpeg, maybe I won't do, okay, and then SVID, and then move. Let's see. Okay. Okay. Okay, so this is the original video itself. It's the outgoing President Obama. Sad. With his daughter and Michelle Obama at the in Selma. It's not a long clip. It's like 1 minute and 30 seconds. And essentially, the use case was like, okay, this is great. It's very high quality. How do I do different stuff with it, right? Like, how do I generate different data out of it? So there are some initial things that we can do with FFmpeg that are useful, like with the I flag. Basically, what this is going to do, it's going to generate a bunch of metadata that's stored in this particular file, right? So it's encoding the date that it was created, where it was uploaded to, its size, its extent, and different codecs that are used for handling it. So that's initially useful information as sort of like for like provenance and things like that. If you wanted to do something like, create a segment out of this, you could do that with FFmpeg. So these particular flags, it's just saying, start at the 60th second, the SS60, and with T to subset the data, basically within a 20-second window, and then to input that file as the source file. Whoop. So if we hit that, it's going to be moving through every frame. Slowly subsetting. And then we should have 20-second clip that starts at the 60th second. Okay. So I'm going to close that. The original video is pretty big, particularly when your internet is fussy. This one's 128 megabytes. If you wanted to make it easier to share it DTU, you could do something like this. So this particular command, all it's doing is just saying change the scale of the film to 640 by 480, generate a new file. It's going to take a little bit. It's going to take a really long bit. Okay. So now, basically, we've gone down to a file that was 128 megabytes to like 18 megabytes. Okay. So kind of like simple, like pragmatic kind of stuff. I think during my workshop, I've said before that creating the GIF is like, hey, if you wanted to share something on the web in a cool way, you could create an animated GIF. I'll let you be the deciders for that. I don't know, how many of you have created animated GIFs before? I'm noticing the same hands going up. Yeah, it's like the same. Let's see. So if we have this here, wait. We have this here. We now have an animated GIF, right? So it's basically just a single image cycling through that you could put on the web somewhere. Okay. Now, in the interest of time, I'm going to skip the last two commands. Essentially, it's just how do you separate out an audio track from a video file, and then how do you edit that down? Right. So pretty straightforward stuff. Maybe more of like a public history orientation. Like if you're interested in doing like, documenting a particular community and putting it on the web. It's like a simple, but powerful local tool that you can use that's open source to edit video and generate it into new formats and things like that. Okay, we're on the last thing. We're almost there. Okay, and this one is actually really short. Let's see. So it's the FFmpeg plus ImageMagick. One of the great things about ImageMagick for the Windows users, once you get it installed, is that you invoke it or you activate the program by just typing magic. It's pretty good, right? Okay, so essentially I'm going to recreate part of the workflow for Scared to Death, the visualization of the Bela Lugosi thing. So if I go up again, and then I'm going to make a directory called Scared to Death. I'll go into that directory. And then I'll make two folders, one called Jumbo and one called Small. Okay, and let's see here. And then I'm going to move Scared to Death. Let's see, .mp4, move the file in there. Okay. Scared to Death. Okay, and this is the command that I used at the time. So it's basically just saying input a file, and then every 4 seconds, create a JPEG. And this particular component right here just creates the number of spaces to accommodate a growing file name. Sometimes that needs to be bigger or larger depending upon how many different files you're generating. Okay. Oh. Wait, but I want to be in the jumbo folder. CD jumbo. And I think I can do. Oh. Okay. So this is going to take a while because it's going to generate, I think it's like 1,200 images or 1,000 individual images out of the single video file. Okay, all done. So, scared to death. If we go into jumbo, yeah, we have over 1,000 images. Okay. Now we use image magic to make the montage. And that's a really simple command, right? So just saying montage, activate the montage capacity in image magic. We put a wildcard or an asterisk in front of JPEG to say basically every file that has a JPEG extension. Combine all of those and make a new file called jumbo montage. Okay. Done. And then in jumbo at the very bottom here, we've generated a montage, right? And you can zoom in or out for the entire movie. Okay. So there are an additional few commands in this particular section, but in the interest of time, I think because we're toward the end, I think I'll conclude the tutorial part there. I think we have until 5, so it's like 14 minutes. But at this point, I think I'll probably just circulate around. Use your pink flags if you have the energy and will, and I'll try and stop by. Okay? of stuff.
My brain.
Yeah.
I'll play with this later.
Cool.
Are you working at UCSB?
Yeah, we're used to
I
it.
live in Lofton.
Oh, cool. It's beautiful.
I
Huh?
live near. Oh,
Yeah, yeah,
love that area.
yeah. Yeah, it's nice. Hi. I'll come around.
Yeah. A little bit unsure if I install these yet.
Okay.
I see. I see you have the directory. Software. You think I got it
Yeah, so it's,
correctly?
yeah, so I think it's, I included a link in Slack,
Yeah, okay.
and that one will go to the executable, like the .exe. It goes directly to it
Yeah.
as a download.
Okay.
And then you should be good.
I do that from the beginning because that I have not opened yet. So yeah. I try. Yeah, now I'm out. Yeah, I'll go there from your on your link.
Okay, great.
Great speech.
Oh, thank you. Thank you. Thank you.
Oh, there you go. Hello. Hi. I have some updates for you, but just to follow up on what James and Thomas were doing with their talks. So we're talking about what the researchers are doing. I think a lot of the examples we saw were in the digital humanities, like sort of exploration, the analysis that they're trying to do with text. One thing that I like to turn around and say, it's not only helpful, to understand what the researchers are doing, but we can turn that around and use it in our own work in libraries. And so here's an example of a project that takes advantage of some of the things that they talked about. So I used to work at the European Southern Observatory, and the European Southern Observatory, I think we talked about bibliometrics earlier. They were very concerned about tracking what was happening in the research, what was happening in scientific literature that used data from their facilities. Data citation, even in astronomy at the moment, is still not, like where we would want it to be. And so I would have to use the same mechanisms that they were talking about to sift through the literature. So I used this facility called the Astrophysics Data Systems, which pointed to links to papers. And I would extract the text from those PDFs and use keywords in the papers to basically find out if people had cited our data, if they'd mentioned that they were using European Southern Observatory data. Then we would find those mentions. So you see in this part right here, this is sort of a triage area where you can faintly see like some of the program IDs and other things that they're using in their papers. And so what we would do is link that back. So we would start assigning all those program IDs, and ultimately it built this nice bibliography of all the links that generated our bibliometrics. in a way, we were facilitating data linking. That goes back into the astrophysics data systems. And so now astronomers, when they're searching the literature, they don't even know that libraries have produced those data links for them, but they love it. You know, they'll talk about how seamless it is for them to go from a paper to a data set. But on the other end, it was ironic in the sense that our curation activities were driven by these bibliometrics. This need to understand how the facilities were doing in comparison to others. And just as a side note, I hope no ESO people are watching, but through this kind of analysis, we found out that Scandinavians were the most efficient, most productive in using the telescopes. So that never really went out there, but we could understand how the facilities were being used through this. It's just an example for you to understand. Maybe on the other hand, you can also use this in your own work. And I very much like that, the fact that we're working almost similarly as our researchers. So it's easier, you know, we're doing it in our work, but it's easier for us to speak to them. And because of this, I actually, I don't have an astronomy background, but because I understood this stuff, I could have conversations with the astronomers about these various things. And just to give you another example, we worked with some researchers on a particular project. They wrote in a particular journal, and they wanted to understand data citation in that journal. And so in a similar way, and that journal happened to be with Elsevier. So we were lucky to get the full text files from Elsevier because they wanted to benefit from the data linking as well. So we mined the literature for links to data, and it informed a best practices paper that was widely read in the domain. So this is, you know, something you could do as you're thinking about your data services, is work with a particular group and understanding how this is. Getting access to this full text is a challenge. You know, open access is still sort of a dream that hasn't been fully realized. So one thing we were trying to look at before was that what I noticed in Pedro's talk is that PLOS is heavily used. There are a lot of people writing in PLOS here at DTU. So PLOS had a public data release, and that would be, you know, fantastic to look through that and understand how people are sort of, you know, what their best practices are at the moment in writing for PLOS, and if anything can be improved. So just some ideas for you in the library context and sort of the crossover between the groups. But updates. So we're actually going to be here for a while until the bus comes at 6:15. So you have some time to maybe also catch up on your work emails. So tomorrow we're going to have GitHub training, Git training. And I highly recommend, since you saw what happened today, to download the GitHub desktop tool and follow the instructions that they provided to get ready for tomorrow. And also to put that into context too, like, it's been a struggle to understand how in libraries we might be able to employ GitHub. You know, the sort of underlying concepts of versioning and collaborative authoring. And here's some examples, you know, just one thing that I'm thinking about. Does everyone know libguides or libguides? Do you know that there's like 1,000 libguides on one subject? You know, like by subject librarians, they produce thousands of libguides that are almost the same. And so the tragic thing is, if you could use a tool like GitHub to sort of collaboratively build a guide together, you reduce all this redundancy that's happening. And you know, in some ways, I'm thinking about that for my own community. One of the questions on Twitter was, how do I take what I've learned here and use it in my own work. And so I'm looking at how in the libraries you can do that. So with my own group, trying to think about how they can use GitHub for their own guides or their tips and tricks or other things that they want to share with the researchers. And there is a project management tool in GitHub now, so maybe we'll explore that. But as you're looking at it tomorrow, have that in mind. And I'll have something else to maybe say about that tomorrow. But did I miss anything else with updates?
No updates, but I think we should give our two speakers today a big hand for being here. And also, I think you should give yourself a hand for staying in to this. And